Today, we are pulling back the curtain on one of the most powerful, and let's be honest, sometimes confusing parts of Kubernetes. We're talking about how it automatically dishes out persistent storage for your stateful applications whenever you need it. Okay, so here's our game plan. First, we'll look at the old way versus the new way. Then we'll dive into the magic behind it all, storage classes. After that, we'll see how this stuff actually works on AWS, Azure, and GCP. Then we'll get into the fun stuff, managing storage after it's been created. And finally, we'll wrap it all up by figuring out how to pick the perfect storage for your apps. Let's get into it.
To really appreciate just how slick dynamic provisioning is, you first have to feel the pain of the old way. We're talking about the manual headaches and all that operational friction.
And this slide just lays it all out, doesn't it? On the left, you've got the old way. It was a slow, ticket-driven nightmare with way too many steps and handoffs. But look at the right, that's the new way. A developer just says, hey, I need some storage, and boom, Kubernetes takes care of everything else. It's a total game changer.
Okay, but that automation, it's not actually magic, right? It's powered by a super important Kubernetes resource. So how in the world does Kubernetes take that one simple request from a developer and turn it into a real live disk with all the right settings?
Well, the answer is the storage class. Seriously, this is the cornerstone of the whole system. The best way to think about it is like a menu of storage options. The admin sets up the menu, fast SSDs, cheap hard drives, encrypted volumes, you name it, and developers can just order what they need. And if you look at the parts of a storage class, you can see how it gives you so much control. The provisioner is just who's making the disk. Is it AWS, GCP, someone else? The parameters are the specific options, like disk type or encryption. Reclaim policy is super important. Do we delete the disk when we're done or keep it? And those last two, allow volume expansion and volume binding mode, they give us some really neat operational tricks, as we're about to see.
So this brings us to a classic, and I mean classic, Kubernetes trap. Imagine your storage gets created in availability zone A, but the Kubernetes scheduler puts your pod in zone B. Well, your pod is going to get stuck. It just won't start because it can't reach its disk across zones. Ouch.
And here is the beautiful, elegant solution. You just set that volume binding mode to wait for first consumer. Check out this flow. Instead of making the disk right away, Kubernetes just waits. It figures out where the pod is going to run first, and then it tells the storage system to create the disk in that exact same zone. Problem solved. The zone trap is completely avoided.
All right, enough with the theory. Let's see how this stuff actually plays out in the real world. We're going to look at how the big three cloud providers, AWS, Azure, and GCP, handle all of this.
Now, before we get into the details, we got to give a shout out to the unsung hero here, the Container Storage Interface, or CSI. Think of it as a universal adapter. It lets all these different storage systems plug into Kubernetes using the same standard language. But, and this is a big but, what each cloud actually gives you under the hood can be wildly different.
This table is awesome. It breaks it all down. You can see they all have their own names for disk types, but look down at that high availability feature. This is a big one. AWS EBS volumes are stuck in a single zone, but Azure and GCP, they both offer options that automatically replicate your data across zones. For high availability, that can be an absolute lifesaver.
Hey, and if you're running on AWS, listen up, because this quote right here is pure gold. With the old GP2 volumes, performance was tied to size. So if you needed more speed, you had to pay for a bigger disk, even if you didn't need the space. The new GB3 type changes all that. You can tune performance and size separately. It's a massive cost saver, for real.
Okay, so getting your storage provisioned, that's just day one. The real power comes from what you can do afterwards. We're talking about managing that storage throughout its entire life cycle as your application grows and changes.
I mean, check this out. It is so cool. Your application is running out of space? No problem. As long as your storage class is set up for it, you literally just change one number in your config file. Kubernetes does the rest. It resizes the physical disk in the cloud, then it expands the file system on the node, all without any downtime for your app. It's amazing. Okay, deep breath. This next part is super important, which is why it gets its own slide. This is a one-way street. You can grow a volume as much as you want, but you cannot shrink it using the Kubernetes API. It's a safety feature, really. Trying to shrink a live disk is just way too risky.
So you're probably asking, well, what if I messed up and made a volume way too big? Don't worry, there's a safe workaround. You just create a new, smaller volume, copy all your data over, point your app to the new one, and then you can safely delete that oversized, expensive old volume.
Let's talk backups. Kubernetes has a really slick API for snapshots. And what's so clever about it is that it perfectly mirrors the storage model we've already learned. The admin sets up a volume snapshot class, which is the how, and the developer just asks for a volume snapshot, which is the what. It keeps the policy separate from the action, which is a really smart design.
Now, when it's time to restore, there's one key rule you have to remember. You never, ever restore over an existing volume. Instead, you create a brand new claim and you use this data source field to point it to your snapshot. This spins up a totally new disk, fresh with all the data from that backup. It's clean, it's safe.
All right, we've covered a ton of ground, so let's bring it all home. How do you actually pick the right storage class for your specific workload? Well, it really all boils down to a balancing act between three things: performance, cost, and reliability.
First things first, you have to know your application. Is it all about IOPS, lots of small random reads and writes like a database? Or is it all about throughput, shoving huge streams of data, like for logging or big data processing? Answering that single question is probably the most important step to picking the right disk. And then, of course, there's the bill. We all want to save money, so here are my top 3 tips. 1. Use volume expansion to your advantage. Start small and grow. 2. For your dev and test environments, always use a reclaim policy of delete. You don't want to be paying for a bunch of forgotten disks. And 3, use lifecycle policies to move your old snapshots to cheaper archival storage.
So after all of that, what's the big idea here? If you remember just one thing from this whole explainer, what should it be?
This is it. This is the fundamental shift. Storage is no longer a ticket you file with the IT department and wait for. It's now a dynamic resource that's part of your application's own code. It lives in your YAML files, it's checked into Git right next to everything else. This is true infrastructure as code.
And you know, when you see how powerful this declarative model is, it gets you thinking, what's next? We've pretty much nailed this for block storage. So the next frontier has to be object storage, right? There's a new standard coming called CoSI, the Container Object Storage Interface. Will it bring this same automated declarative magic to things like S3 buckets? That is a very exciting space to watch.